2.
Hi everyone, welcome back to the Rice Museum. My name is Dylan, and today I'm going to be telling you a little bit about the rock cycle. Now, the rock cycle is one of the most basic things in geology, and what most people need to know about the rock cycle is that there are three main types of rocks, and those three main types of rocks will remain throughout the rock cycle, and they can change into each other, and they're always constantly intertwined. The three types of rocks are actually igneous rocks, sedimentary rocks, and metamorphic rocks. And today I'm going to talk to you about all three, and first we are actually going to start with these igneous rocks right here. All of these examples right here on this table are examples of igneous rocks. Now, igneous rocks themselves are created by volcanoes, specifically from magma or lava. Now, the difference between the two is magma is still inside the volcano. It's still in the magma chamber deep inside the ground. Whereas lava is after the volcano has erupted, all that molten rock that comes out of the volcano and spews out becomes lava. Right here, we have a piece of granite. Now, this piece of granite was cooled in a magma chamber. And the way we know that is by all the colors and the size of the crystals you're actually seeing in here. So, you see three main colors in this piece of granite. The white in here is called quartz, the pink is feldspar, and the black is mica. Now, the reason why we can see all three colors, and even as I move this in the light, you might be able to see some of the crystalline in here. The reason for that is because magma chambers are obviously very hot, and these rocks need heat to grow and to cool. Sorry, not to cool. They need heat to grow and to expand and to separate. Because of the heat, you see all of these different colors. It allows the quartz and the mica and the feldspar to all separate, and it allows these crystals to grow even bigger. Now, if you took this rock and say it was molten rock and it was jettisoned out of a volcano, it would have become lava, not magma. And so it would have cooled to look something more like this. This is a piece of rhyolite, a little bit more bland, a little bit more gray, and that's because this came out of the volcano and cooled much faster, at a much faster rate than this granite did, which meant that none of the colors got to separate and none of those crystals began to grow. So everything in this rock is actually all the same ingredients in that piece of quartz or that piece of granite I just showed you. But because it cooled so fast, you don't get to see any of that separation. Now, if you let something cool even faster than rhyolite, you get something like this. This is called volcanic glass, also known as obsidian. This stuff is extremely sharp. Even today, it is still used in the medical field for things like scalpels, but this was also used for a lot of Native American tools like spears and arrowheads. Next up, we have this. This big rock is called pumice. It's actually incredibly light and filled with air bubbles. It's mostly here to make me look strong for all the kids that normally come in here. This is formed while lava is coming barreling down the side of a volcano. It traps a bunch of air and ash and bubbles inside this rock, and as it cools, it solidifies and leaves all this air trapped in here, which means this rock is substantially hollow. If I were to drop this in a bucket of water, it could potentially float. If you took a rock like this pumice, or any of these other igneous rocks, and you beat them up with wind, with water, with rain, they will begin to erode and break up into many different pieces. And those pieces are called sediments. And that's where this next section comes in. And these are our sedimentary rocks. Now, sedimentary rocks only occur from sediments after sediments sit there for a long time and accumulate enough pressure and slowly form together to become rocks. We have a few different sediments up here, and I'm here to tell you all about them. Pebbles. Pebbles is actually a sediment. Most people think of them as just small rocks, but you have enough of them together, it's technically considered a type of sediment. Sand from a beach, obviously a sediment. From there, we have silt that you would normally find maybe at the bottom of rivers, also considered a sediment, as clay is as well. And clay is probably one of the finest sediments you can find. Each of these types of sediments will make a different type of sedimentary rock. Sand will obviously make sandstone, where you can find many fossils like you see right here. You also can get some of this beautiful red sandstone if you find some sandstone in deserts. Silt over here will make siltstone, which often looks like this black stone right here. It's very smooth, and you can also find fossils in this. Clay over here will make shale, which is probably not the most exciting rock, but it's still kind of cool because of its smooth, and this looks like the bottom of a river, which it potentially was. Now, we have clay that makes shale, we have silt that makes siltstone, we have sand that makes sandstone, and then we have pebbles that make a conglomerate. And I couldn't tell you why they decided to name it a conglomerate instead of pebblestone, but for some reason they did. Now, this piece of shale that I held up a second ago, I find this a little bit more boring compared to a lot of the rocks that we have here at the museum. But that's because I know what this rock can turn into and what it can become. And that's due to the next section. So this next section of rock right here is called metamorphic rocks. Now, metamorphic rocks are probably some of the more fascinating rocks that we have. And the reason for that is because of the change they go through. Very much like a butterfly or like a caterpillar goes into a cocoon and becomes a butterfly. I mean, these rocks don't start off as little worms, but they start off as any of these other types of rocks in here. Then they get shoved deep down into the Earth's crust, close to the mantle, and they start to cook at very high heat and very high pressure. And once that happens, they start to transform into something completely different. The boring piece of shale I had right here doesn't look like much, right? But if you shove this down into the Earth's crust, eventually it would transform into something like this, which is called slate with pyrite. And you can see all the little pieces of pyrite in throughout this giant piece of rock. If you took this and put this deeper into the crust and closer to the mantle, a little bit more high heat, a little bit more high pressure, it would turn into something like this, called mica schist. And this has some of the most beautiful foiling I've seen on a rock, in all honesty. This is one of my favorites to hold and to look at just because of the colors and just the shininess to it. If you took this and you shoved it down even deeper, this would transform into something else called garnet schist. For anybody born in January, this is where your birthstone comes from. Down deep in the crust and the mantle is where these gemstones called garnets are formed. And it all starts from that boring piece of shale I showed you originally. And you can find all of these deep in the metamorphic layer of rocks. The final rock I want to talk to you about is this big piece of rock right here. This rock is gneiss. And it's not just the rock itself is nice, but it's also called gneiss, spelled Gneiss. Now, this rock, aside from being one of the final stages of metamorphic rocks, this is potentially the heaviest and the hardest type of rock there is on Earth, as you can hear. So, thank you for listening to me talk about the rock cycle, and I hope you guys stick around to see what else we have to show you here.